The work we're doing is related to the development of technologies to convert and store energy, because right now sustainability is a big challenge for humanity. The energy consumption increases at the rate of 2 to 3% per year. And so it's not a sustainable way to live, it's not a sustainable way to run the economy. So what we do is to work on the development of technologies to convert and store energy. And to develop those technologies, we need material that can store energy at fast rate and with a high efficiency. And so what we do is to develop predictive computer models in order to predict the ability of a material to store energy. And then we use artificial intelligence and machine learning to be able to accelerate the explorations of millions of possible materials compositions. And so based on that, we can work with our experimental colleagues in order to accelerate the development of those materials. At the practical level, it is extremely interesting to be able to predict the properties of materials before they are made. And a lot of companies have understood the opportunity that exists in that field, in particular the big tech companies that work on AI. The impact is also scientific, in that we're developing new techniques that can then be applied widely in any area of material science. We can have an impact on the development of materials using those computational techniques accelerated with artificial intelligence and machine learning. And the impact is also at the educational level. So currently, I have an international appointment with cmu-africa. The goal of what I'm doing there is to help develop a curriculum in material science for master students on the cmu-africa campus. And I feel this is an extraordinary opportunity for African students, because using computers and using your imagination, you can conceive some new materials that then going to be integrated in new technologies. So this research already has some interesting success. So we have worked with our experimental colleagues in order to explore large space of materials composition. So starting from hundreds of thousands of materials, we're able to do calculation in the computer to predict their properties and their performance, their stability. The next challenge for us is to be able to take our predictions that can be applied to hundreds of thousands of materials and extend that to millions and hundreds of millions of different materials composition. So this is really the challenge right now in the field, and we're developing the algorithm. We're incorporating AI and machine learning to be able to achieve that type of predictive power. And so the goal is that one day, when you want to make a material, you will be able to conceive it in the computer, and with a high rate of success, be able to synthesize it in order to incorporate them in the technologies that we need to solve some of the big problems faced by humanity.